Hello everyone, welcome to Lesson 5 from Chapter 5. Compare and order rational numbers. This lesson is found on page 387. When we talk about rational numbers, we're talking about any number that can be written as a fraction, a number that can be written over 1, mixed number, percent, or decimal. Insects. The length of several common types of insects are shown in the table. Which of the insects is the longest? Okay, so let's look at the insects. Here's our list, and here's their length in inches, right? Well, we're being asked which one is the longest. Let's see. This one is 3/4. This one is 1. It's a full one. This is 1/3. Again, 3/4. So this one ties this one. This one is only 1/4. Here we have a half, and then 5/8. Remember, I've asked you many times to memorize how to count by eighths. So you're counting by 12.5%. Okay? I see the longest as being the only whole number. The cricket is the longest. Shade each fraction strip to represent the length of a fire ant and a housefly. Which is longer? The fire ant or the housefly? Okay, so we have fire ant, which is right over here. Fire ant, right? And then we have the housefly. We're going to shade in first for the housefly. Okay, or well, yes, because we have all 1/4. Okay, so the housefly is only 1/4 right here. Okay, and the fire ant is 1/3 right there. So you can see, okay, that 1/3 is a little bit bigger. Sorry, like there. It's a bit bigger than 1/4 by this much right here, by this area. Okay, so 1/3 is bigger than 1/4. And you know that 1/3 is 33.3% bar notation, and 1/4 is 25%, right? So which one's longer? The fire ant. It's 1/3. You can see that it's longer. How many of the insects are longer than 0.5 inches, than half an inch? How many are longer than half? So 3/4. Half of 4, right here, half of 4 is 2. Is this bigger than 2? Yes, so this is bigger than half. Okay, half of 1, this is a whole, so that's bigger than half. What's half of 3? 1.5. This is less than 1.5, so not that one. Half of 4 is 2. Remember, we're looking for what's bigger than half. So 3/4 is also bigger. 1/4 is not, because half of 4 is 2. What's half of 1 Japanese beetle? Well, we're being asked which one's larger than a half. This is not larger than a half, this is exactly a half. And what's half of 8? 4. Is this larger than 4? Yes, it is, so that's also larger than half. And there we have it. So the mosquito, the firefly, the cricket, and the green June beetle are larger than a half. Remember, the question was how many insects? Well, 4 insects. Number 4. Order the length of a housefly, a green June beetle, a fire ant from shortest to longest. Shortest to longest, don't forget that. Okay, we have the green June beetle at 3/4, the housefly at 1/4. Okay, so clearly the housefly is smaller than the green June beetle. And the fire ant, there's 1/3. And we already know that 1/3 is larger than 1/4. Okay, so it's 1/4, 1/3, and then 3/4. And there you have it. We have our housefly, our fire ant, and our green June beetle, from shortest to longest. Okay, just like we did in lesson 1, we can use a number line to compare values. Positive and negative rational numbers can be represented on a number line. You can use a number line to help you compare and order rational numbers. Here's what we mean by a number line. And I know that if I have, for example, the number 2, it would be right here. But if I have -1.5, -1 is right here, and then another half of negative will be right there. So I would put my little mark right about there. And now I know that 2 is larger than -1.5, right? Because they get larger as you go down to the right and smaller as you go to the left. And now you can see in example 1 that we are comparing by using the symbols less than, greater than, or equal to. Okay, and we're going to compare a negative with a positive. Well, we know the positive is going to be larger, right, than the negative. But you can test it out by putting it on the number line, and you see it as they go further to the right, they get larger. Further to the left, they get smaller. And here it's, since negative decimal 1-2 is to the left of 0.8, negative 1.2 is less than 0.8. And there you go, boys and girls. For example 2, you'll be asked to actually graph these on the number line, okay, where we graph them right here, and you have to put these numbers on the number line to compare them. Remember, as the negative number gets larger, it's actually getting smaller in value, okay? And you can see that here on our vertical line. Okay, it's a vertical line where we have the numbers this way getting larger and this way getting smaller. So as they go further down, the negative numbers actually looks like it becomes a higher number, but it's of lesser value. Another way to compare them is by finding a common denominator, the least common denominator, and whatever you do to the bottom, you must do to the top. So you understand over here that a common denominator, a common multiple, would be 16, because if you count by 8, you'll say 8, 16 will be your second number, and 16 here is your first number. So let's find the common denominator, okay, where we put the 16. I'll just put 16 over both of them, okay. That's not good, 16. 16 over both of them. What did I do to this 8 to make it 16? I doubled it, so I must do the same thing to this negative 3, so it becomes negative 6, okay. And what did I do to this 16? Nothing. So what do I do to this negative 5? Nothing. Okay, so this one's negative 5. Remember, as the negative number gets bigger, it's actually getting smaller in value. So this is a smaller value than negative 5. Remember, negative 5 is closer to the 0, which is becoming in the direction of a positive number. And when we check it, you can see here that we are correct. But they wrote it in the original way, negative 3/8. Okay, so if you are confident, you can go ahead and pause the video and try these 4 on your own, and then play the video again to check your answers. Please pause now. Okay, the first one's pretty straightforward. We have a positive number and a negative number. The negative number is always smaller, okay? So 3.1 is larger than negative 3.7. Number 2, we have both negative numbers. But you can see that, remember, as the negative number gets bigger, it's actually losing value. So this is 50 here would be 50, while this one's 49. So clearly this number over here, this negative number, because it's getting larger than this number, but it's negative, it's actually a smaller number. Over here we have a common denominator of 16. Okay, and so we just have to go up by the numerator, and I see that the numerator is smaller on this side, so 9/16 is less than 12/16. Okay, and finally, we don't have a common denominator here, but we can tell that it's 10, right? Common denominator is 10. They're both multiples of 5. I didn't have to do anything to this 10, so I do nothing to the negative 7. And what did I do to this 5? I doubled it, so I must do the same to the 4, and it becomes negative 8. Okay, this number is larger. It's a larger negative number than this number. A larger negative number has lesser value. Don't forget that. So there we have it. So there's your answer. To compare and order rational numbers, first write them in the same form. Meaning, if they're both mixed numbers, write them into improper fraction and find a common denominator, and so on. Okay, make sure that you find a common denominator so that it's easy to compare the numerators. Or if they're written as a decimal and a fraction, make sure you write them both either as decimals or both as fractions. As you can see by this example, this one was written as a decimal, okay, to compare to this decimal. You could also write this one as a fraction, 51 over 100, right? And then you can find a common denominator between 15 and 100. Or you can use a number line once you've changed them both to decimals. And over here we were given a decimal, whole number with a decimal, then a mixed number and a mixed number. And the person that did this decided to change them all to decimals, okay? So this is decimal negative 2.1, and this one is almost a half, right? Actually, no, almost a whole, almost 3. And this one's almost a half. So you can see how they match up in terms of decimals. Okay, if you're feeling confident again, please pause the video and try this on your own, and then see if you did it correctly. Now we have negative 5/8. Now remember, I've told you to memorize the count by eighths. And I know that 4 over 8, let me zoom this in for you to see better. 4 over 8 is 50%. Every 1/8 is 12.5%, right? 12.5%, or as a decimal, 0.125. Every single 1/8. So if I add that to 4/8, that brings me up to 5/8. So I'm adding these three values together in reality. You know that this would be 3. Here's your 3, right? -3, I guess. Here's your 3. And then 4/8 would be 50%. But I'm going to add another 1 to make it 5/8. And another 1 is 125. Remember 12.5% written as a decimal? If I add these two together, I'm going to get 62.5. 3.625. You see that? So these two are equal. And this is why I told you, boys and girls, memorize to count by 8s. For f, we know that to convert them both into the same, I could divide the 3 divided by 7. And I know that 3 is slightly less than half, because half of 7 is 3.5. Right? Half of 7. So this is going to be slightly less than half. And so is this. So are they the same? I don't know until I divide the 3 divided by 7. I hope you tried this on the side as I'm doing now. There are no 7s in 3. 7s are there in 30. I know there's 4. Gives me 28. Subtract, I have another 2. I bring down. Now I have 2. Gives me 14. I have 6. Bring another 0 down. Right? And now 7 times 8. 7 times 8 is 56. Right? And now I'm back to, now I have 4. And 7 times 5. I'm going to stop there because I have enough decimal places to work with. I have 0.42, while here I have 4.1. So clearly 3/7 is greater than 0.413. Well, I just realized I did all of this and I had not pressed the recording button. So let me just explain what I did now. Okay? For this last part, okay, I looked at the numbers. I looked at these 3 numbers here, and I know that it has to be from greatest to least. My greatest, because they're all 3 negative, my greatest will actually be the smallest number. Don't forget that, because it's negative. The negative number, as the number gets bigger in the negative, it actually has less value. It actually has less. So I start looking here, and I see that I have 13/20. 13 is a little bit higher than half, because half of 13 is 10, right? Half of 13, here, half of 13 is 10. So 7 and 10/20 would be 7.5. But this is slightly over half. Then I look here and I have 7.78. This is about 7 3/4, but a little bit more than 3/4. This one's actually becoming almost -8, which is the smallest number of all 3, because it's the highest number in the negative. And here I have 17/100. I know that 17 is less than 25, which is 1/4. So this is less than 1/4. This one's more than half, while this one's about 3/4. So that's how I was able to figure it out. And I know that it goes from greatest to least. So greatest would be the smallest number, because it's the negative. There it is. This one's just slightly over half, so it's the next smallest number, getting into the negative. And then the smallest number is the one that's almost 8, which is really in reality the biggest number, but it's negative. As they get bigger in the negative, they actually lose value. Here we have essentially the same questions, but in words, okay, where you have to order these values from, let's see, you're just comparing the difference between the least and the greatest. So you first have to find out their order, isolate the least, isolate the greatest, and then find their difference. Here's our guided practice. Please leave it for class so we can do it together as a warm-up. And here you have your independent practice. Make sure that you do it all, including the back page. Actually, let's do this together. I know many of you don't watch this part of the video, the end, so this will be a key answer. Please copy all these numbers down as a key answer. Okay, everybody, I'll see you in class.